this part of our tutorial, we're going to talk about the errors and error handling. So let me create a new file and call it error.py. So there are times that we want to skip some of the errors inside of our code, or there are the times that we want to know whether a kind of an error happened and we don't want it to stop our program from working. So for example, we have a software and it throws an error in the middle of an operation, and once that error occurs, our application will close or will not work properly, and it will close instantly. So we don't want that to happen, so we use the error handling. So imagine that you want to, for example, print X, but you have forgotten to define X before printing it. So if I save this code and run it, Python 3 error.py, okay, as you can see, we face an error. It says that name X is not defined. But here, if I want to skip this error and go after the other parts of the code, I can use try, and in the next line I should use an indentation for print. It's better to use tab, and then also I can use except for printing out the fact that this error has occurred. So I can write an error occurred. So let me save this and see what happens here. So as you can see, instead of this long error here, it has shown an error occurred. And here, if I, for example, print 10 or print, let me put it in the quotation marks, 10. If I print 10 here, as you can see, it works just as it should. But here, if we didn't have try and except, it wouldn't have printed 10. So let me comment here the try, the except, and that's it. So here, if I print X, we won't be able to see print 10. Why? Because we face an error, and the error makes the code to stop, makes the running of the program to stop. But if I use the error handling method or code here, it will go on and it will let us know that an error occurred. So in your application, whatever it is, whether it's a web application or a desktop application or a mobile application, anywhere you are, you can use the error handling in order for the program or the application to continue and let the user know that an error occurred by opening up an alert or showing something to the user, a warning message or something like that. So here, let me rerun the code, and as you can see, again, an error occurred and the number 10 has been printed out. So you can write a lot of codes after it and it will work without raising any error or interfering the program itself. You can also define an error. So for example, you see that a certain number, you can set a rule or a condition. So for example, if X is less than, so for example, let me define X, and for example, it's less than 0, so it's -3. So here I can say that, for example, if X is less than 0, which means it's negative, I can raise an exception, raise an error. So exception, and I can write the number has to be positive. I can say the number shouldn't be negative because here we want to also include 0. Okay, here let me see what happens. As you can see, we've raised an error, and Python has shown us that kind of error that we've raised, and it says the number shouldn't be negative, just the same as we've printed out. So we can also raise an error. So this is a kind of an error handling. For example, we want to write a module, and we have certain rules for our variables and inputs. And if those errors occur, it will raise an error and it raises an exception. It will let us know what that exception is. And this is most of the time useful for writing a module, not for a program. You use this in order for the users of the module who want to use it in their own program and test it, in order to see if an exception happens if they've done anything wrong. But you don't use it for programs, you don't use it for applications generally, because it will stop the application from running and it will not be useful. So anyway, the more useful one is using try and except. But that's not the end of the story, because there are times that we have different exceptions. For example, here we haven't defined x, and we have a built-in error that Python raises for us when we do not try and except. We want then that error in order to be printed out, and if that error didn't happen, then we can write another except and write our own kind of error. Or if any error hasn't happened, we can say that no error has occurred. And we have other statements as well for try and except, which I'm going to tell you in the following of the tutorial. So here we can write, instead of except, we can write name error, except name error, and here we can print out the name error itself instead of writing our own statement. So name error, and we can print it out. So let's see what happens here. So as you can see, it says class name error. It doesn't say the error. Or we can write as error and print out only error. Save this, and the same goes on. Name x is not defined. So here, error tells us what the error is, instead of writing only the class name error. So name x is not defined. It shows us exactly what is the error, instead of raising a very long exception here that we cannot find what is it all about. It tells us exactly what the error is in just one line, and it does the rest of the code, prints out and does certain operations like printing 10, as you can see here, after the code that we've written. There are other types of error, like value error, OS error, which are related to their own kind of error. You should, as a programmer, you should know that what kind of error that is. However, if you don't know that, you can write other excepts. So except value error as error, and then print error. Or you can write another except for the OS error, which is related to your operating system. For example, you want to open a kind of a file and it doesn't open up because that file does not exist in the directory that you're looking for it. So you can use OS error as error, and if that error happens anytime, it will show an error. So for example, you have written a kind of a program, and oftentimes you face an error in some parts of it, and those errors are very common. So for those lines of your code, you can use you can put that line of code in try and then you can use different kinds of excepts in order for the user to understand, or the coder in order to understand what kind of error he or she is facing. So here, let me save the code and see what happens. As you can see, again, name X is not defined, and here I can also print out the type of error it faces. So for example, you can write name error. It says class. It does the same for the class of value error and OS error. So you will understand what the error is and what type of error that is. But it's not very useful to write the kind of error. What matters is what the error actually is, and is not very much concerned about the type of error. So here OS with capital S and E with capital E. Also, let me fix this about the value error. Rerun the code and see what happens. So we can see that it's a name error, not value error, not OS error, but name error. So anyway, if you use this for the parts of the code that you know that something is wrong or something wrong might happen sometime or oftentimes, and you can write all of this for that part of the code in order to know what that kind of that error is and what that error says, and also let other parts of the code to continue. This is very much better for error handling. And also, if nothing else happened, you can write else at the end, and say that print no error occurred. And also you can use, instead of else, you can use finally, or next after else you can write finally, and then print error handling finished. So either you face an error or everything goes right, you will see this finally anyway. But if no error occurs, you will see no error occurred, or if you see any kind of error, you will see the type of it. So for example, if I declare X or define X before try and except, here you will face no error, you will print X, and finally it says no error occurred, and finally it says error handling finished. So as you can see, the number -3 is printed out, no error occurred, error handling finished, and then the rest of the code. And if I comment X equals -3, what you will see is you will see the type of error, what the error is, and then you will see that error handling is finished, and you will see the rest of the code results like just printing 10. Okay, that's it for handling errors, and it is a very helpful part of Python programming and other programming languages. This one will help you manage most of the parts of your codes much better and understand the errors even better, and let other programmers know what your problem is. But before finishing this part, I'm also going to create and tell you kind of an example. So for example, you want to have a nested kind of a try. So you may have different kinds of errors, not the ones related to name error, value error, or OS error. You have a kind of a compound error. So for example, you want to open a kind of a file, and then that file is not found, whether it's found or not found in the directory that you are in. This is one error. And then you want to read from that file that you have opened up, and you'll face an error for reading what is inside that file. That is another kind of error. So first of all, because these two are related to each other, you need to use the kind of a nested try. So for example, you write try, and then you, for example, open. I'm not going to talk about opening the files because it's a subject of another tutorial, but for example, we have open function. I'm not going to talk about it yet, but just going to tell you an example. And then you put another try for reading from that file, and then you will raise an error or catch an error actually for the second try, the try inside the other try, and say that an error occurred, example, an error occurred for reading. And also you can catch another except for printing out the error of opening the file. So if no file is found, it says that no such file found. No such file found. And if it opens up successfully, it says that, and there's a problem in reading the file, it says that an error occurred for reading the file, okay, for reading what is inside of the file. So this is a kind of a nested try, but this is related to opening the files or something, some other example that you can find, but these are the conditional kind of tries. So if the first one happens and is all right, we enter the next try. But if this one doesn't happen and we face an error, we won't be able to enter into the next try. So it doesn't make sense to write another try in the same indentation as this try. Why? Because if you cannot open the file, you definitely cannot read the file either. And that's why sometimes we use this kind of a nested try. However, it's not very common, but in some circumstances you need to use this kind of error handling, which is a nested one.